Hello everyone, this is section 2.6 continued. I am going to go through a couple more transformations. I just want to make sure we see the things happening. I do want to go through possibly two more examples, and I did draw new functions, so it looks a little different than the one we had in the first video. But similar. Again, we have three straight line pieces, so when we shift them, stretch them, smush them, whatever we do to them, they will also be three straight line pieces. So it's not going to be a traumatic change. So the first one I'm going to look at, and we are working with G, so I'm going to put a 2 on the inside, and we will do a +1 on the outside. Okay, remembering that when we are on the outside of functions, we are going to be affecting those y values, and they work normal. So like here's my y value, adding 1 to it. When we're inside, we're kind of directly affecting that x, and we affect that x kind of in a weird way. We kind of work backwards. So we're affecting this x not by multiplying, but actually by dividing. So this 2, and again we do follow order of operations, so we're going to take care of the 2 first, and the 2 is on the inside of our function, so we're going to be affecting our x values. And again, when we're inside, things work a little strangely, and I'll talk about why that happens when we kind of are looking at our points. And we'll see how that kind of follows. So this 2 is on the inside, so instead of multiplying that by 2, so instead of thinking it's going to be actually stretching us out, it's actually going to be pushing us in. So this is going to shrink horizontally by a half. I like to think of it as, instead of multiplying those x's by 2, we're going to take our x values and divide them by 2. So every x value is going to be moved in halfway. The second thing we are going to take care of is that +1, that 1 that's on the outside. And that is going to move our graph up 1 unit. And to move things up, we'll take our y and we're going to add 1 to it. Okay. And I'm going to list my original points. I do find that for whatever reason, that tends to help. And this is 1, 2. Granted, you really wouldn't have to do all of the points in there. I tend to do as many as I can to make sure my graph looks right. But if you knew that these were the ends of your line, you could just do those 2 points, connect them, do these 2 points, and so forth. Just connect the points on the ends of your line, straight line pieces. But I do like to add a few extras in there, just to make sure. And we're at 3, and that's 4, 1. So there's our original points of our graphs. Those are the originals, and we're going to go through and do the steps. And I'm going to do one at a time again, just to make sure we don't make mistakes. So this is going to take my x values, and it's going to bring them in halfway. So this -1 is going to move to a half. And the reason it works this way is because what we would do is, this would be my x value. It's going to go into the function, and then the first thing that happens is it gets multiplied by 2 to turn back into the -1. So then I would know that I'm going to be here. So I want to move this point in so that whatever value here was is going to represent that point. So we have to kind of undo the multiplication in there. I don't know if that made sense, but maybe it did. Here, we're not moving 0, so it's going to stay there because 0 divided by 2 is still 0. This is moving in a half. This is moving in a half. And I'm going to leave that as in fraction form. That is moving in a half. And this is moving in a half. Hopefully you guys can see those. Maybe I can zoom in a little bit. There. That can help a little bit. And I'm going to draw those in so we can kind of see them. So everything's kind of moving in halfway. It causes things to get a little steeper as well, so it's kind of smushing it all in. And this guy's moving all the way here. So I don't know if you can kind of, there he is, whoops. Yeah, smoosh it in. But keep this guy the same. So this guy's got to come in, which is going to cause everything to move over. And the next thing we want to do is add that 1. So we're going to shift it up 1 unit. So we're going to be taking care of that up 1. So that's going to take my y's and go up 1. My y values, and I'm going to go up 1. Up 1. Up 1. And I will put that here as well, so we can get our final answer here. Let's see, that's 0. Whoops, 0, 2. I can't add here. 1 half 3. There we go. Half 3. 1, 1. 3 halves, which is 1 1/2, negative 1. And 2, 2. Ah. That is really drawn badly, but these points on a graph, and there you go. Okay, I'm going to choose a graph now that we know, a function that we know. And I'm going to pick, let's just draw y equals, and let's go with 1/3 absolute value x minus 1 plus 2. Okay, so we're going to sketch this guy. And so what we have to remember is our basic function is what this absolute value function. So I'm going to be drawing our absolute value function over here. And it's the one that starts at 0, 0, and it is our v function. So 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3, and it continues on forever. Okay? So when we transform it or shift it and stretch it and smush it, this thing is going to still look like a V of some sort. Okay, so where do we start? Notice this minus 1 is inside that absolute value function, so it's going to affect our x's, and it's going to affect them backwards. These two values are outside that absolute value function, so it's kind of outside the function. It will affect our y values, and it will act normally. Now the order of operations says we start inside first, so we're going to take care of this minus 1 first, then we'll take care of our multiplying, and then we'll do our adding and subtracting. So we're going to be doing it that form. So this minus 1 is inside our function, so it's going to be affecting our x values, and it's going to shift things, not the negative direction, but our positive direction, so shift things to the right 1 unit. And we can see that happen if we take our x's and we add 1 to it. Then we'll take care of this next step. So the 1/3 is on the outside, so it's going to affect our y's, and this is going to, since it's less than 1, we will see a shrink, possibly. It's hard to see with the V, but we will see a shrink horizontally. It's going to be shrunk down by 1/3. So to do that, we're going to take our y's and multiply by 1/3. Such beautiful numbers. And then we're going to move it up 2 units, because that's the plus 2 is going to shift it all up 2. And to get it to shift up, we're going to take those y values from here and then add 2. So again, we have 3 things we're going to be doing, because we have 3 values that we've done. So I'm going to start with our original problems, original points. Whoops, let's go with 0, 0, 1. Let's start with this guy. 2, 2, 3, 3, our negative 1, 1, and I'll put in negative 2, 2, so we can kind of, and we'll throw in negative 3, 3. So we've got quite a few points. So first thing I'm going to do is I'm going to shift it to the right. So we're going to take care of that minus 1 by adding 1 to our x's. So 1, 0, 2, 1, 3, 2, 4, 3. 0, 1, negative 1, 2, and negative 2, 3. Okay, and I could plot those if I wanted to. I'm just going to plot the final answer so that it doesn't clutter up my graph too much. But you can see this point's going to shift, so it would be at 1, 0, and so forth. So we're shifting it over 1 unit, shifting it over 1 unit. Then we're going to shrink it. So we're going to take those y values and multiply by 1/3. So if you want to write yourself little notes of what you're doing, that might help. So we're taking the y values. So the x values don't change. Four and 1. 0 and 1/3. Negative 1 2/3. Negative 2, 1. And our last thing is we're going to go up 2, so we're going to add 2 to all the y's. So up 2. So 1, 2, 2, and if I do 2 in terms of thirds, that is 6/3. So this would be 7/3. This would be 8/3, and this would be, we're up to 3, 7/3, 8/3, 9/3, or 3. And I'm going to put this one in, I think purple. Actually, yeah, the purple. So 1, and we'll have a point at 1, 2. So 2 7/3. So that's like 2 1/3, right? 3 8/3. So that's going to be a little bit below there. 4 1 2 3. 0 7/3. Negative 1 8/3. And negative 2 there. So we'll see a very flat, if I can draw a flat, V. Our V point has moved over and moved up, and then it's gotten smushed down or flattened a little bit. So there are a couple more examples of some transformations. Hopefully doing these points idea helps. Some people will still, shift it 1, smush it down, and they'll draw 3 separate pictures, and that works fine too. Whatever method works best for you. Again, I prefer the points idea because it keeps everything crystal clear to me, but some people are more visual, so they want to see the shift to the right, the smushing of the graph, then physically moving it up 2 units. So I do have one more video in this unit in section 2.6 that's going to discuss even and odd functions.